Why, thank you. That's enough of that. Okay, good day. My name's Peter, discussing Hut 34 once again. Thank you for tuning in. We're going to be making a series of these sort of shorter videos. Some of them will be deeper dives, some of them will be more surface, explaining some of the concepts and where we're up to with our mission to power the data economy. We're now at the process where we're starting to release into production a few of our data relays, using the first cut of our data exchange protocol HUDX, using our encryption service, using our wallet to interact with the Ethereum blockchain to read and write information, all in the name of allowing parties to trustlessly exchange data. And obviously we're very excited by some of the possibilities that this unlocks. It's our mission really at Hut 34 to make agile data, to make people's data more valuable, to make it more able to collect, secure, share, and to do all this following best practice in terms of security and encryption, and also unlocking new opportunities through a path to decentralization, which if you're watching this, you're probably already familiar with some of those concepts, and hopefully you're as into them as I am. So today we're going to talk just a little bit about the two important factors or two important pillars of how we achieve what we do. One of which is HUTX, which is our protocol for the trustless exchange of data, and the other of which is just a little look at our smart contract suite. So that's just the first cut of the smart contracts which power our applications to read and write information to and from both the blockchain and distributed storage, for which we use IPFS, the Interplanetary File System. Okay, so if you understand most of this, then do continue. We'll also try to make a few more of these videos from time to time, so you'll see some that just cover the surface information, some of the key concepts, and some of which go a little bit deeper in. So without further ado, here we go. Okay, so we're looking at Hut 34, and as I said, today we're going to really focus on the smart contract suite and what is this thing that I mentioned called HUTX. So what we're looking at here is the discrete information theory smart contract. Both the entropy token, which is the unit, the medium of exchange, the unit of value within our ecosystem, and the discrete information theory contract are tipping their hat toward a mathematical giant in the space, a guy called Claude Shannon, who did some amazingly prescient and sort of well ahead of its time research into information theory and informational entropy. So he's the reason that we have our the nomenclature of our token and this smart contract. And really this smart contract is not it's not doing a huge amount of compute or really doing anything that complex. It's just a conduit to allow our applications to read and write information, as we're about to see. So now we're going to take a walk down the public record. What is on the blockchain, and how can I understand what is happening at the hut that has resulted in this blockchain and this distributed storage, this information, this data. So we're looking here at a transaction from a few days ago, or a couple of days ago, which is a HUDX transaction. It's called the method HUDX transaction complete here, and it's sent a bunch of data to the chain. So here you go. If we decode the data, we'll see that it's written two things, and it cost us, zero. Value was zero. It cost us 0.8 cents to write this information, and this information stored a string, which is an IPFS hash, and a transaction hash, which is a transaction string. So what this is doing is binding this transaction to this piece of data. So this is the first instance where we've bound data to value. We're going to see this transaction hash again in a minute, so I'll explain what it is. But many of you may already be familiar with this string, which is an IPFS location string. It's the hash of the IPFS location. So always begins QM, and we're going to use a third party. We don't use Cloudflare's gateway, but any IPFS gateway, such as Cloudflare's, which I'm using here, can retrieve this string. And you'll see here that that's what's on the chain. So immediately we know that 2 days ago there was this transaction, and this was the data. Now this data is a base 64 encoded version of our HUTX object. So I've already done this, but I'll do it again here. Just pop it into any encoder, and it decodes the JSON. There's JSON there, and let's just move forward. Here's one I made earlier, which shows us the HUTX object. So this is the output from the HUTX protocol. So we've seen a transaction from a couple of days ago. We've seen the discrete information theory smart contract. We've seen a specific transaction from a couple of days ago. We've now pinged IPFS to get the data. We've decoded it, and now we're looking at it here. First up, the value aspect. Now, the value of all HUTX objects today is a valid 0x object. In fact, it's a settled 0x object at this point, because you can see that settlement hash is again repeated here. So there it is. There are reasons we're doing an on-chain record here, as well as a base 64 encoded version within the JSON object, but it's doubled up information basically. So here's the 0x object, and 0x of course being a way to relay signed transactions, and for any party, any second party, so you've got a maker who creates the order and signs it, and that's distributed around the relays, and then you've got a taker who pays the gas to submit it to the blockchain, to the 0x contract, and the 0x contract does the transfer of the assets. All of the appropriate information required is within this object, so our protocol effectively extends 0x, there's value, and we extend that by applying a model and some data to it. I'm going to keep this quite brief right now, because this is doing really quite a simple version of the HUTX protocol. What this is doing is the model is public, as you can see, so it allows other people, agents, machines, software can examine the model that's being exchanged and can see a little bit more information. So they've got the versioning of the HUTX, the application ID if present, columns, data, location, and keys, etc., etc. And this is telling us a little bit of meta information about the data that's been exchanged. What we're excited about here is that as those transactions pile up, you can actually feed information from the chain, decode the HUTX object into things like machine learning and into software that can see what's going, can enable effectively a marketplace becomes a buffet. It helps people to select the data they want. It allows people to draw correlations or to make specific queries really against disparate data sets to pull out the data that they want, and ultimately they can you can have fine-grained valuations as well, so you can exchange portions of your data for value, etc., etc. But here we have a maker and a taker string, that's the HUTX string, and another IPFS hash. Let's first of all go down the rabbit hole just one further step, which is to say let's have a look at what's at this IPFS hash. It's a different IPFS hash, and again we'll use Cloudflare, and we'll see that we've got a big long encrypted string. That's as far as we can go publicly. We've got some sense of whether this data, of course, could contain locations for further encrypted data. It could contain keys for further encrypted data. It could contain anything. We don't know because it's encrypted. And that's exactly the way it should be. We don't have any information about the parties transacting, and we can see that there is a payload. The payload has been described in a way that the party who offered that data, effectively the seller of that data, has determined that certain information is available publicly. And then we've got our encryption service here. Now, I won't go into too much detail in this conversation about how we're approaching that. It's actually an area that's a little bit fluid, but at the moment we create each transaction, each HUTX transaction creates an ephemeral Ethereum address, the private key of which is encrypted using an RSA key pair which is registered on-chain. So in practice, what that means is that this is an encrypted Ethereum address private key. That's what both these strings are. And the maker version is an encrypted Ethereum private key that's been encrypted using the on-chain registered RSA public key of the maker. And the taker encryption key, because it has settled, is the same private key encrypted using the taker's RSA public key. And if we go back to the contract for a moment, you'll see that we've got some ability to read and write datas. Now, these are sort of, you can read and write RSA key pairs. You can read the public key. Anyone can read the public key, and you can also write back we can use an Ethereum address private key as an AES encryption key and write the encrypted RSA private key to the chain if we so wish. It's these sort of things that we're playing with at the moment to explore issues of scaling, issues of compute, what is possible, how secure is it, how fast is it, what are the costs, etc., etc. But that's what this is HUTX version, what have we got here? The versioning 0.0.1. So it's the very first one out the gate. And this is an encrypted ephemeral Ethereum address private key, which that Ethereum address's private key will allow you to decrypt this string if you're the taker, or this string if you're the maker, to find the RSA private key which decrypts this long string. And were I sitting within a Hut marketplace, we've built some exciting tools which I look forward to introducing to you, to go directly from a user to sign in, click once, purchase or download your data, and start creating actionable insights immediately. All powered under the hood by this trustless data exchange technology. So thank you for watching. That is a slightly longer than intended introduction to HutX, first of many videos, or fourth of many videos, we trust. Thanks for your time, and see you again soon. Onwards and Hutwards.